Hello everyone, welcome to Course Seated. So now we'll be revising the subset sum. Basically last time I was unable to explain it perfectly, but now this time I'll try to make it as perfect as possible. So in subset sum what you have to do? Well, then tuition, you have to exclude the number or include the number. Whether you can reach the target by excluding the number or you can reach the target by including the number. So for that well just imagine this. You have a set, okay? 1 2 3 4 5. uh, First thing you can do, you can write the brute force code. Well, basically the order of n square code, or order of much more than n square brute force code. Well, what will be your brute force code? Well, you'll have to check for 1 plus 2 whether this will give us target or not. Then you will remove 1. Then you will do 1 plus 2 plus 3 plus 4 plus 5. Then you will check whether this can give us target or not. Basically, you will check all the subsets one by one. But so we'll be doing the same using DP, but there is a catch that we'll be returning if we have already checked that sum. So basically, if we try to do it using loop for integer I equals 0, I less than n, I plus plus, and then for j, basically no, not this, j equals to 0, j less than n, j plus plus, and then we'll have for integer k equals to I, k less than equals j, k plus plus, and then we'll have to check. Then we can just check whether we can do that by doing this or not. And even in that, it's not impossible to get it wrong, and you will have to just use loop again and again. So basically, there will be n loops for n stuff, which will make your code very bad. So let me first write that brute force code, then explain it to you. Okay, so I have thought the brute force code now. Now I'll be first explaining you the intuition behind it, then we'll be writing the code. So basically in brute force, you have to check every possible subset. As you know, I've already told you that basically over here. So next we'll have to choose whether we have to pick the number or not. Even in that, pick the number slash not pick the number, not pick the number. Okay, so for that you can just start with an example 3 4 and 7 maybe, and your target will be target equals let's say 7. So suppose you have this target, so what you can do, you have the target as 7, right? So what you can do is you can imagine your set like this, and then you have to include 3 or not, whether. So first start with 3. So we have this 3 over here. Basically I equals a0 equals 3, ai equals a0 equals 3, and then a1 equals 4, and then a2 equals 7. So basically there are two ways to reach that target. First is 3 plus 4, second is 7 directly. So first we'll have this. First you'll include the 3, include 3. Then you can say that target is 7 minus, so your target was 7. So you'll just subtract the 3 from there, and then you will check whether 4 is present or not by any sum method. Next you can exclude the 3. In that way you can just say that target equals to 7, target remains 7. So basically this is the target, new target, and here new target is still the same as target. New target equals 7, new target equals 4 over here. So for then you check for both the paths. Well, basically this is tree. Well, basically in tree you just have to travel all the paths Basically, it is very much like tree. So if I would have taught you about tree, you would have been getting this very much along with it. So on the website, I'll be teaching everything properly, line wise line, basically topic wise. Each topic will have some relevance to the previous topic, and we won't be jumping like this on our website. So basically, you can just go to course seated, as I've already told you about this in previous lecture. So the courses will start from 1st May and 10th May. And then we'll be bringing a system design course, which is, well, before that we'll be first doing the game development course using Godot, which will come on Godot 4, which will come on basically 1st August. Yeah, basically it will be August. So remember the date, 1st, 10th, and 1st August. So basically over here we have to go to these two paths. 7 was there, then you can go to 4 or 7, then you can go to 4 or 0. Basically if 0 is there, then target has been reached, and then you can go to 0 or 7 again. So basically if 0 is there, then target has been reached. So over here include 4, exclude 4, exclude 4, and over here you have include 4, exclude 4. So basically, sorry, 7, 7. So basically this will give you a lot of space. I mean, you'll have to use a lots of space for this. So basically space optimization over here is something that you can use, but then your time complexity will increase. So we always prefer time complexity in competitive programming, and we always use a space optimization, or you can say space complexity, for system design, well, at least most of the time. And for uh, when we use time complexity again, if we are basically both, not just time, both time complexity and space complexity for HFT firms, well, basically for trading companies, or trading companies. So this is what you need to become a master of DSA in C++. So if you become a master of DSA in C++, you are bound to get some job. So that's not a problem. And as you can see, I've never clickbaited anyone. So this, what I'm saying, is actually the truth. I've seen multiple people getting just by knowing about DSA. So it was include 7, exclude 7. Then now we can write first the recursive code. So basically we'll be first writing the recursion code, which is the brute force method, you can say. So this is our brute force method. Brute force method. Well, brute force method is the worst method that you can use in competitive programming, but sometimes since constraints are small, you can use brute force method if you need. So first we'll have I'll be writing the code now. So you have subset sum, and what you can do, well, brute force. Let's write brute force over here. First you'll have to pass obviously numbers, and then target, and then n. N is basically the size of numbers, or you can write this as what was that? Okay, so we need numbers only. Numbers, target, and then n, which was the size. Then if target equals to 0, return true. Well, basically I showed you over here. If target equals 0, then we have reached what we needed. So return true. And if n equals 0, then return false. And in case of false, we'll be returning -1. Okay, so we are done with these two. Next we have if numbers of n minus 1. Well, basically, if the last digit, or you can say the last number in your vector or array is greater than the target, then you have to just call the subset, will return subset, basically this name, all of this. I'll be using this as subset only. So subset dot dot dot, and we'll be returning the same stuff, number, target, and then n minus 1. Well, basically then it will go to n minus 2, then n minus 3, then n minus 4. Well, well, we are going from left, right to left. And suppose if we sort this, then it might get even faster. Well, basically in Java, we sort the function. Then, basically we don't sort. We randomize the function first. Then we sort the function. Well, randomization helps a lot. Basically, if your, compiler is forcefully executing or doing some other stuff. So randomization helps a lot in Java. Anyways, over here we don't need randomization because this is C++ where sort function actually has everything already in it. So we can return subset sum dot dot dot, and we have number, target, well, so basically I forgot to tell you this. We have two choices. Choice one is to include the last element, and choice 2 is to exclude the last element. So how can you do these two stuff? Well, don't go why this is giving you the answer. Just remember that doing these two, well, there is some proof, there is some mathematical way to prove this, that you will get the answer. Just remember that including and excluding helps a lot in DP problems, and you have to check how to include and how to exclude. Basically your math should be strong for that. Anyways, I was at return subset sum and dot dot dot. Then we'll have number, target, and n minus 1. And suppose this means we are including, and second we can use or subset sum and dot 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 nums. Then we'll have target minus array. Okay, so we are at nums n minus 1 comma n minus 1. Well, basically what this is doing, this means that you are including, sorry, this means you are including, this means you are excluding. So basically I told you that when you will include, you'll have 7 minus 4 equals 7 minus 3 equals 4, right? So you'll have something like this, that number minus, so basically this was your target, so you have a target, and then you'll have number I. Basically I is your just index. So over here we are since changing n again and again, so I have n minus 1 over here. So this is what you are getting, target minus nums I. I mean, this time you should have surely got it. Okay, so someone has come. Let me just greet them, then I'll be coming back to you. Okay, so I'm back. So basically, we were at including and excluding. So first we have to include and then target minus nums I. Now you should have already got what you need with the proof. So basically that means we are including, and that means that we are excluding, and this will happen again and again for every number. So to reduce this from happening again and again, we'll just use DP. So first write the brute force code. Let's write the brute force code first, then we'll be explaining the DP part. Okay, so we are at we should return integer. You first tell me whether we should return boolean data type, integer data type, vector data type, or we should be returning void. If you chose integer, then you are wrong. If you chose boolean, then you are correct. So let's continue now. Well, basically, this these two slashes, double straight slash means, well, these two double straight slash means or. So basically, what we are doing here an or that'll do there too. So let's just continue with that. Okay, so we have now written the code. So basically, if target equals 0, return true. If n double equals 0, return false. If number n minus 1 at index n minus 1 is greater than target, then return subset sum with nums target and n minus 1. Then return subset n minus 1, and we have nums, and then we have target, and afterwards we have this n minus 1 target minus nums n minus 1. Well, basically this means include, this means exclude. You can write that in your code that this one means include and this one means exclude, and then you can write over there the example that I told you in your notes. That will be basically the best thing to do. Okay, so now we just have to take the input from here, and then we can just write our code, and then we can check whether it is correct or not. So basically for target, I'll be taking some, what do we say there? I'll be taking some vector for targets so that we can implement that in one go. Well, basically what I mean is I'll write over here. So if you're asked for multiple targets, don't write over here vector in target. Just leave it at in target, and then we can just call them one by one. Basically there are m targets. It's not necessary that the targets will be same as as numbers, so I'm writing this as m. But we'll have to take small targets because otherwise our recursion will give us time limit exceeded, so we'll be using small targets for now. So let me first write, then we'll be going to next part. And also you have to think that you can use some other you can use some other method to check the subset sum. Suppose if target is 10 to the power 9 and you have only one test case, so basically that will give us time limit exceeded over here. But if you just check it one by one for every number, that won't give us any time limit exceeded. So basically what I mean is you can use the for loop where it is necessary, or you can use the recursion where it is needed, or you can use the DP where you see it perfect. So you'll have to, basically a best programmer is not someone who you know knows how to code everywhere, mm, or code everything, but the one who can implement the best thing at the best spot. You are getting me right? Okay, so first we have to take n and m, so I'll be taking 7 and 10. Or we can take our own example which we took over here. So it was basically of three numbers, I believe. Yeah, so n was 3 and target was 7, and we'll have multiple targets for it, 3, 4 and 7. Okay, so we'll have 10 targets. First we'll have to write what our array will be. It will be 3, 4, 7, and then we'll take 0 as the target, and second target will be 1. Next it will be 2, 3. Okay, so since we have written this, we can just implement. So basically for this we have to see out something, so I'll just check whether it is true or not. Basically you don't have to write true over here. Basically if any function returns you true value, you can just leave it without this and you will get the answer. It's not just for function, any boolean data type, if it gives you true, you don't need to write double equals true. Basically you can do this, but I am just writing so that you can understand it, because you might not be a pro yet and you might have forgotten how to do this. Anyways, so if this condition is true, basically if we reach the target, then we'll just see out that target reached. So how am I able to get from here to directly there? Well, basically I'm using the end command on basically a keyword, or you can say the key end. In your keyboard you will find a key that says end, basically end. That will just throw you at the end of the line. It just basically throws your cursor at the end of the line. So this should be in your, this is the power of end key. And suppose you want to reach back to the first, well basically here or maybe here, then you'll have to use home key. Okay, so home key takes you there, end key takes you at the end of the line. And next we have insert key, ins. It'll just uh, do some weird thing. Basically it won't just erase left, it'll erase from right too. Or you can use the delete function to erase the right and not erase the left, and backspace to erase the left and not to erase the right. So these are some key about something about keyboard. So basically when we'll be designing a keyboard, we will keep things in our mind such as this. So just remember that home helps you get at the first line and first text of the line, and end helps you get at the last text of the line, and backspace, delete, and insert do some other stuff. Well, basically, I'll give you a chart for that when we'll be designing the keyboard. Okay, so I'll have to write this again. Well, basically, we'll have from 0 to 10. Now let's see what all we can reach. Okay, so we are able to reach 0, but we failed to reach the target 1 or 2. Okay, so it was 2. Let me write the target over here. Okay, so now we'll have the greatest output. Okay, we have written target over here instead of target. Okay, so target 0 was reached using nums. Failed to reach the target 2. Target 3 was reached using nums, and so on. So let's see if that's correct. So basically no 2 is there, so we were unable to reach 2. That's correct. 3 was there, 4 was there, 5 we can't reach, 6 we can't reach, 7 we can reach using 3 4 and 7 2. So this can be reached. And we can't reach 8 and 9. That's correct. And next we can reach the 10 using 7 and 3. So perfect, we are getting perfect answers now. So basically this is the brute force method, which was as simple as this. Next you'll have to write the DP. Take few seconds to think how you will implement the DP. So basically nothing will change. You just have to remember that target, nums, and target minus nums. Okay, so let's move to the DP. So basically in DP you just store it in a 2D vector or 1D sometimes. So basically logic won't change, you will just have to write. Okay, so what will be our setup? Well, DP method. So our setup will be DP row. Okay, so there will be a DP row and column. Well, basically we'll be taking row over here and column over here. We can just reverse this if we want, because we can just flip the whole table like this if we want, or we can rotate it by 90 degree, you can say. We don't have to flip, we just have to rotate it by 90 degree to change the row and column as we need. Okay, so what was our setup? We can use rows as numbers we are allowed to use. We can use rows as numbers we are allowed to use first, and then second we have columns as possible sum from 0 to target. Well, basically in DP we will just go from left to right instead of going from, well, basically instead of subtracting we can add 2 if we want, but I believe subtracting is the best method to currently do for this. So this is the step 1, you can say setup is your step 1, and second we have step 2. Well, in DP you always have to remember that first step will be your setup. Second step, you will have to write what dpij is, or basically row column is. So dpij is always, since 0 is always possible, so what you will fill it with this, or the initials in dp, that will write. Basically, when we always wrote dp0 equals 0, dp1 equals 1, these were our basically step 2. So here we'll write for 2D DP. So basically sum 0 is always possible, as you know, always possible, always possible, always possible. So what we'll be doing, we'll just, since our column is for sum, so these all will be true for 0th index, 0th index, these all will be true, 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 true. Basically we can get 0 whenever we want, so for all numbers we'll have true as the answer. Okay, so next we have sum greater than 0. If sum is greater than 0, then we know what we have to do. Basically over here, if sum was greater than target, then we return the subset, so we'll be just returning the dp of n minus 1. Correct? You must have got this now. So you can just write your brute force method and then you can convert it directly into dp without thinking anything, because you just have to think a bit for dp if you know the recursion. So if sum is greater than 0, then dp n minus 1 should be returned. Basically dpi comma n minus 1, return dpi n. Well, we have to return this. And third we have logic. Well, logic is this only. Well, basically if target has been reached, then you don't need to subtract anything. Otherwise you just need to fill dpi target minus nums I. Yes, so you'll have this. Well, basically this was our sum. Our target has changed to sum, as we know. So we'll just have to write it like this. So sum minus nums I. So this is the correct approach. Okay, so this was actually J. And well, basically this has sum, not J. Well, so we can write this. First step, dpi 0 equals to true. First step done. Second step, we have, well, basically we have to fill the table. So if that is the case, then we'll just do dpij equals dpi minus 1j. Okay, so basically over here, not n minus 1 over here. Basically if sum is greater than 0, then you have to change what? If, well, basically if sum was greater than, where is our code? Okay, so if sum was greater than 0, basically if it was greater than target, then we have, okay, so if number was greater than at sum, then we have to return dp of I minus 1 and the sum. Okay, well, that should be the case, dp I minus 1 and then the sum. Well, basically this has to be done. And second, we have just the basic. Well, basically we have to return this next. So that will be our logic. Next, we can write the code. So let me write the code. Well, this time, since I don't remember the code what we'll have written in the last lecture, I might write a new code. So if you have already copied and understood the last code, then you don't need to write this. Otherwise, you will have to write this too. Okay, so we have a DP. Basically, I can return word over here. Okay, so we have subset some DP, and we have the maximum of target. Well, we'll be choosing the max target over here so that we can get all the targets in the range. So we'll just do it like this something. Well, basically why I'm sorting this, so that we can get the largest target at the end of targets, and then we can just pass it once in the DP and we'll have the answer for all, for all the targets. So I can write it over here now, vector int nums. So now we have our DP. Next, what will we be writing? We will be basically writing this over here. So we have n, we have target, and we have nums, and we have DP. So basically we'll be doing DP. What was our so first we have the step one, DPI 0 equals true. Okay, so for everything, well, basically from 0 to target, well, 0 you have to include, and you can just think to yourself why you have to include. And second, we have to include the target too, because if you exclude the target, then there is no chance it will give you the answer. So you have to include the target as well. Since okay, so we don't have to do it like this. We'll just be doing it like this. Basically, you have to include the target too. Well, we'll be doing that in sums. Well, over here you have to write n because you need n, obviously. Well, basically, I'm doing it from 1 to n. Well, let me tell you why. Well, because first thing, for all the 0, we have already made it true, so we don't need to include 0 over here again. So second, so we'll be starting from I equals to 1. Okay, so did I do something wrong? No, no, no. I've written everything right. So for I equals to 0, we already have true as the answer. And for I equals to 1 and sum equals to 0. So basically I equals 0 to n, v, and sum equals 0. We have true as the answer. is this for I equal to 0 to n. And second, this was the first thing we have to do. And second, we can use rows as number as we are allowed to use. Okay. That was basically our step one. Second, we have DPI is the initial thing. Okay, we have done this. Now third, we have logic. If sum is greater than 0, return DPI minus 1 and sum. Okay, so this was in the logic basically. I wrote it in the initials, but this was in the logic. So second, we have already initialized. Well, this was our second part, not first. Second, first DP, second this. Third, we'll have to use loop for I to n. Well, basically 1 to n or 0 to n. Let me think. Well, basically for 1 to n. We'll just have, then for 1 to target. Okay. Because for 0th target we have written everything. And for 0th I we don't need to write because what can I say? Because that will always be false, or you can just say that we don't need that. So basically, why will that be false? Let me tell you that first. So suppose we have 0, 1, 2, 3, and for 0. So if this was true and if this was false, then everything will stay false. Well, basically, we are unable to get, well, if target equals 3 and num equals 3. Well, so, okay. So basically, we need everything from 0 to n, but we are doing it from 1 to n because we, where is our dp? Yes, so we have to take dp I minus 1, which will automatically move it from 0 to n minus 1. Okay, so you got me now. 0 to n minus 1. This implies dp I minus 1. So basically, we are doing I minus 1, so we have to start from 1 to n. And we'll be doing dp I equals this. So basically, that's the reason that we have to start from 1 to n. And second, we have 1 to target because for every 0, you have answer as true, answer set as true already. So both are from 1 to target and 1 to n. So next we have okay. So if num size is greater than target sum, then what do you have to do? Well, basically, from our brute force code, we can see that we have to return subset for I minus 1. Basically, in our case, it will be return. Well, that was brute force code. I'm sorry. So we have to just return dp. So well, so we have 2d dp. So I'm writing n over here, but we should write I. And second, we have target sum. second we have I minus 1 and target sum. Then we can just change this to else. I actually wrote wrong 4 times or 5 times maybe. So next, you already know what we have to return. Well, but basically we have to return dp of I minus 1 and target, and dp of I minus 1 and target minus nums of I minus 1. So let's write that, and then we can just we are good to go. So basically we were doing that uh, target and minus 1. Okay, so here we didn't have to write this, I think, because we already wrote this n minus 1 greater than target, then we have to do this. So over here we just have to write this. Well, but in what do I say that? Suppose if this was less than target, uh, and it didn't have to be included in that, then you have to exclude it using this. But in DP, you know that this will already get excluded. So that's the reason DP takes one less. Well, basically, it does not form a tree over here. Where was the tree? So okay, it won't form a tree over here. So that's the reason DP has less time complexity in our subset sum case, even though it has 2D DP in it. Well, basically, it has two-dimensional vector. So we'll be doing DP I minus 1 and J. Well, basically, no, actually, if I write that, then that will be a problem. No, so yeah, we're on the right track. We have to do for both. Well, actually, the problem will be that we won't be able to call this, then we won't be able to exclude that. And in DP also, you have to exclude that. But I thought that this will exclude directly, but that might not be the case. Okay, so we have to write both the things. Well, basically, well, I can do one more thing over here, that I can call this function like for like in every case I can call this. So we don't have to write this actually. So basically, if it is less than equals to target, then we can return this DP. And if a target is greater than equals or anything, then we can just return this. That would be better than doing that. But both will just give same time complexity, because if else you can just reverse them. But that might look cooler to you. So I thought of doing that. Anyways, we'll write target sum, and then we'll write or. Then we'll just return DP I comma target sum. Well, over here you'll have to just remove that from the target sum, number I. Okay. Well, this should give us the answer. Next, we don't have to return anything. We just have this, and then we can just go here, and then we can just call it. Yes. So everything looks perfect to me. Well, if we have missed anything, that will be our doomsday, you can say. Okay, so we can just set everything now. So what all do we need? We need, okay, so I removed that icon. We need all this. Then we'll have for target. So we just have to introduce a DP over here, and then we can just uh, well, actually I started crashing out. For how long have I been teaching? Okay, so for whenever we move more than 40 minutes, I start crashing for some reason. Well, might be 40 minutes is my capability right now for teaching you all. So we have vector, vector bool, n plus 1. Okay, so we need a 2D vector. I've already taught you how to take a 2D vector, right? Well, I'm doing this target m minus 1 because we just need just need the biggest target, or I can just write it like this. Or, or we can do it like this, and biggest target. Okay, so biggest target equals targets of m minus 1, target at m minus 1 index. Then we can pass this over here, biggest target. Then if the vector doesn't change, you'll have all the answers. So let's call that what do we have? Let's call the target now. So basically we don't have to call recursion again and again. We are done just doing it once and we'll have the answer forever. That's actually a beautiful way to understand DP. So at first you might have thought that DP is waste for in 1D DP, because we can already do that using for loops and there is no need of any DP. But in 2D DP you might have understood that we need DP for storing data and doing other stuff. So basically this is very helpful in server creation. So basically when you will be writing SQL, you don't need DP obviously over there, but when you will be writing the backend of SQL or backend of your server, you might need DP for better servers. Well, when I'll be teaching about servers, I'll be teaching you that too. Well, we have much to cover and we might take 5 to 10 years to complete everything about computers on course seeded. And after that, we'll move to some good game creations and sprite creations. Well, basically, we'll do good things too. Well, there will be a fun class where we'll be drawing some crazy, you can say, sprites for our game. I'm thinking of taking that fun class tomorrow at on 29th April will be the fun class. Well, basically on every 29th of the month, we'll be having a fun class. Okay, everyone. So we have now vector bool. We can just now call whatever we need. So I'll just pass this and just tell you what the answer will be. Okay, so we need DP. Mm, okay, so we need a DPN and then target. Yeah, so we need the target. This will give us some boolean value, so we can just pass this in if conditional statement, and then we'll just write whatever we need. So if this is true, Then we'll be printing that dp. We'll be basically doing this. Target at this was reached using nums. We have failed to reach the target using nums, and we can just run this. I hope I don't have written anything wrong anywhere. Okay, so we need this. Well, we basically need till the last one. Okay, so we have biggest target plus one false, and what we are getting wrong? Uh, let's first run this. Okay, so let's see what we are getting wrong. Well, basically this was boolean data type. Okay, yes, so we are returning it a boolean data type. Okay, so oh no, no, I get it. We don't have to return anything in a void function. We don't return anything. Last time I didn't return, and this time I'm returning when we don't have to return. Well, I really start crashing out after 40 minutes. And next we have, okay, targets. It was targets, not target. Yes, so now we have debugged everything. Now we should get the answer. So failed to reach all the targets. That's even crazier than what I thought. LSNN, I plus plus, no sorry. LSNN, sorry. Okay, so this is correct, this is correct. Next we have targets. Okay, so this was also done. Targets m minus 1. Okay, so we might have to check the whole DP for this, but that will be problematic. Well, basically, if we have to check the whole DP, then it's problematic, obviously. But we only need n, I believe. So why we are getting it wrong? Let's see. Okay, mm, so we have mm, so we have it like, oh, now I get it. No, actually I didn't. So first we have everything as false, set to false. Then we have done this to right, to true. Next, what do we have to do? For integer I equals 0, I less than equals n, I plus plus, we have set everything to true. And then we have this range from 1 to n and 1 to target. And then next we have if nums I. Okay. So if nums I minus 1 greater than sum, then we have to do this. And for n we don't have any nums, then what will we do? Oh, that's actually problematic. Well, let's see what we are getting first. And then nums I minus 1, nums I minus 1. Okay, so everything looks perfect, but other than this, everything looks perfect to me. Yes, this was bound to happen. So we have 1 to n greater than, I mean, okay, so let me write this. Now let's see if we have it right or not. Okay, so we are still getting it wrong. Let me just quickly fix it. Well, okay, so this is correct. That is also correct. Okay, so target sum, target sum, target sum, target sum, target sum. Everywhere I've written target sum. That's correct, perfectly correct. And then we have I and I minus 1. So I and I, that's perfectly correct. And then we have I minus 1, I minus 1, I minus 1, and then I minus 1. This is also perfectly correct. Then where are we getting it wrong? Well, it won't be able to check for I minus 1. Okay, so let's leave it for now. So I'm just worried that, okay, so for equals to n also it will just print n minus 1. So why was I even wondering? Was it I even worried? So basically, there's no need to worry anything. We have done everything right. There must be some mistake somewhere that we are not returning anything. Well, let's just print the DP first and then we'll check what we have done wrong. Oh, that's even greater. We never called the subset. Well, I'm just a genius. I never called the subset. So sometimes you just forget to call some things and that just makes you wrong. So basically we have subset. Now it should give us the right answer. Mm, 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 mm. Okay, subset some DP it is. Okay, so target 0 reached using nums, failed to reach the target 2 using nums, target 3 reached using nums, 4 reached. As you can see, 3 and 4 can be reached. So we have 3 and 4 as the answer, and 0 is always reached. Then we can't reach 5 and 6, and 7 can be reached by 3, 4, and 7 itself. So we have failed to reach target 8 and 9. 8 and 9 can't be reached, and 10 we can reach. So basically, we have perfectly run the code. So basically, there was no problem in the code. I just forgot to call the function. Anyways, we are done for today. Thank you everyone for joining. Next, we'll be doing the next example of 2DP. So be prepared for that because it will be knapsack. So in knapsack, we just have to, or should I write the question over here first and then you can try it on your own because knapsack is very similar to subset sum. Let me first write the question over here and then you can try it yourself and then we can just, do it tomorrow. Well, but you might not be able to solve that because I haven't taught you about graphs yet. Well, but yes, if you have the capability, then you can solve it. Then 0, 1, 0 and knapsack basically. True and false knapsack. Let's try to ask a difficult question, okay? So you basically have a vector of weights, and you have values, and then you have capacity, and you have to maximize the value. Maximize value. And then you have at each item, at each item, you just have to call. Well, basically that will be our intuition. So we need to find the maximum value. Okay. Well, from these values, you just need to find the maximum value. So for maximum value, you'll just have to like iterate through I items using capacity W. So your last dpn and weight should be equal to maximum value using first I, or basically using n items and items using with capacity W. This you have to write. Well, you can check the question online. Well, basically, I'll also check it tomorrow and then make my own code tomorrow. And I'll try to explain it as best as possible. Well, basically, we wrote a lot today, so it should give you some benefit. First, you always know you have to write the brute force code since you are a beginner, and then you can go to the DB part. Where is the DB? Okay, so you have to go to the DB part only after writing the brute force code. Well, we have not even touched the advanced parts yet of competitive programming. Well, basically, this can be called the advanced part, but I don't think that it's better than. Well, there are many questions that are better than this. So you'll have to just imagine that you are a newly born seed who has to rise. So for that, you just have to remember that you can just do it one by one. So just solve the question yourself, 01 knapsack, and then come tomorrow to check the solution. Thank you, everyone. Thank you for today. So that's it for today. Thank you, everyone.